You're watching DSP Leaders on TelecomTV. This special series of programs is focused on AI in telecoms and is produced in partnership with the ITP. What exactly is artificial intelligence? And perhaps just importantly, what is it not? Once we establish what it is we're dealing with, our attention is inevitably drawn to security. Time to find out Cisco's vision and strategy for AI and how the company looks to thwart encrypted threats. Joining me now is Richard Liu, System Engineer at Cisco. Richard, very nice to meet you.
Hi there, Guy.
Excellent. Richard, before we dive into the security aspects, can you set the scene and explain what we mean when we talk about AI?
Yeah, absolutely. So let's start from basics. Why AI? So I grew up being intrigued by the concept of AI because of science fiction. In fact, Terminator 2 is one of my favorite films where, as we know, Arnold Schwarzenegger plays a cyborg sent back in time from the distant future in order to remove the leader of the human resistance. Now, what's interesting about this is that the war began when an AI called Skynet, tasked with overseeing the country's nuclear defenses, achieved sentience and turned against its human creators. In fact, Terminator is one of my favorites. It's many pieces of science fiction that depicts truly sentient AI, which is able to learn and make decisions just like we do. Now, that's often with horrific results for humanity. It's a concept that may have been coined by author Isaac Asimov in the 60s. Given the prevalence of this type of sci-fi in our culture, it may be unsurprising then that when I tried to find a famous inspirational quote in relation to AI, I was greeted with this quote by the late Professor Stephen Hawking, giving warning about the development of AI and all of its pitfalls. But as I learned more about computing, what we're able to achieve with it, I began to form a much more realistic view of what AI is capable of. So I know we've been locked down for a while, but the last time I went outside, there were certainly no killer robots, and I think that's really important to distinguish between what is science fiction and what is reality. So let's talk a little bit about what is AI then. Take a step back and just explore very briefly what it is. I want to do this to be able to level set. So how do we define AI then? Well, it's really in the name itself. It's artificial intelligence. And what this really means is that we give a machine the artificial man-made capacity and capability to learn. Hence, you often find that the terms machine learning and AI are being used interchangeably, but this is often incorrect. Now, machine learning is really a subset of AI, despite revolving around the same concepts. And perhaps the best way I can put it is this. So a machine learning system aims to give you the answer, but what it doesn't care about are success and optimization, only that it can take what it's learned, whether it's correct or incorrect, readjust itself for the next time. So a very trivial example of this might be looking at handwritten digits and determining what number it is from 0 to 9. So this type of problem usually revolves around classification of an object, whereas an AI will not only aim to provide that answer, but it cares about success and cares about optimization. And in essence, its goal is smart decision making, much like a human. The result is something maybe we can be akin to wisdom. An example of this might be a trading platform. So that's somewhere that we would absolutely care about optimization and correctness. So what drives both of these concepts, though, is mathematics, because that's what it boils down to. It's all essentially statistical analysis with algorithm secret sauce drizzled on to ensure a cohesive end result. So the reason that we choose computers to do this is because we as humans are very slow at number crunching. However, a machine, on the other hand, can do complex statistical analysis extremely quickly. So if you allow me, let's delve into this a little bit further. Now, when it comes to making things, we as humans, we tend to create in our own image. And it may be unsurprising then that the basis of how we created a machine that learns is modeled after ourselves. The first step is some form of stimulus. So something that can be measured or detected that forms a knowledge base, which the machine will then use to learn and infer. Next, it has some sort of storage for the data. So we have our brains to store all the information we receive. So the machine will have hard drives in a storage array. And once it has this data, we then devise an algorithm and train it on how to think. And this is supervised learning. Or in other words, we use techniques for structured data to be fed into the machine as training data, and then we explicitly tell the machine what label or what category a particular entry belongs to. So finally, once it's been trained, we unleash it into the world and we ask it to classify unfamiliar examples. And if it gets it right, then great. Keep going and keep doing that. But if not, we'll tell it what the answer should have been. And it will then take that answer, amalgamate this new information into its repertoire for future use. So, of course, the major caveat here, though, is the old adage, garbage in, garbage out. In other words, the system can only be as good as the data it's given. Bad data will, of course, always skew a system's ability to present a correct answer. Now, I'm not going to go into this too much, but some of you might remember the fiasco that Apple had with the iPhone X, where in Asia it was found that it was a little bit lacking because the face unlock feature could be unlocked by other people. So we don't always get it right. And if we look further, there are other examples of technology which, although technology itself is neither inherently good or bad, it is up to us as a species to be vigilant and ethical in its use and creation. Things such as deepfakes, which is a deep learning AI that can be used to replace someone's face with another in video, which is an extremely scary prospect in our modern age of fake news. But that's maybe a conversation for another day. What I'd like to go on to talk about then is, now that we've had a whistle-stop tour of AI, let's look at what Cisco is doing with AI. So we touched on some of the use cases of AI, but the question remains, why use AI at all? Well, we at Cisco see it this way. We use AI because it gives rise to a number of benefits which we simply cannot achieve with humans. Programming aside, we remove any errors associated with humans, since a computer is able to perform tasks significantly faster than a human can, and with no errors or what we might call fat fingering. Further, there's also the concept of unsupervised machine learning, wherein the goal is to find interesting patterns and correlations in data rather than to explicitly train it to figure these out. Now, these might be utilized where there are large quantities of unstructured data, where we're interested in finding patterns to enable further use cases. So we've talked about some general use cases already, but the majority of consumer use cases are fairly novel. Features such as, I think we've all seen the dog face on Snapchat. Things like this have become a part of our everyday lives and showcases to some of the possibilities of AI. But actually, the uses in industry are perhaps far more interesting. So here you see a matrix of just some of those use cases by industry and domain. Now, I work for a networking company, so I am, of course, going to talk about networking. Specifically, as the title has given away, how we can use AI to protect the network. So, but in fact, using AI for security, that's just one very small part of Cisco's AI strategy. And where we want to go is to pragmatically apply AI to three key areas. So solving networking by providing visibility, actionable insights, and giving proactive alerting to issues before they become outages and problems. We aim to refine and hone our employed data and techniques so that the bias is removed, meaning that the systems we are able to create will be without the skew which can cause so many issues. And finally, we look to see how we can improve the future of working, truly powering an inclusive future for all. And why Cisco? Well, because Cisco has visibility of massive quantities of data from end-to-end networks from all over the globe. And what this gives us is a huge amount of rich, diverse, and high-quality data, which we can then use to train our systems. Not only this, but the market has come to expect and pays attention to our thought leadership in tech. And in turn, we look to the horizon to provide that insight. So with that being said, let's dive into one such application, which I personally think is a really cool piece of tech. And that is called Encrypted Traffic Analytics, or ETA for short. So let's just talk about the problem a little bit first. Now, Gartner and some others have predicted that by 2019, 80% of traffic across our networks will be encrypted. So this is generally a pretty positive thing, because privacy concerns have led to more people becoming security conscious, using encryption technology to protect themselves through the use of VPNs or encrypted instant messaging and other encryption technologies. However, what this means is that this presents the bad guys with a potent attack vector. And what they can then do is hide that malicious traffic in encryption. Remember what I said about technology being neither good nor bad? Now, this is because encrypted traffic can't be picked up by the security devices on the perimeter, as they have no possible or discernible signature since it's encrypted, it's hidden. And this presents organizations with a major headache. So one way that we could potentially deal with this is to have a security perimeter which would decrypt each incoming data flow to determine if there's malicious traffic in there before letting it into the network. But for the sake of business continuity, this is not possible as traffic would slow to a crawl. So audio-sensitive voice or data traffic when your WebEx calls are not going to go through the way that you would want. Add to this the fact that you are essentially, what you're doing is creating a man-in-the-middle attack on yourself. This isn't a very good way to do it, as you're essentially swapping one problem for another and creating all sorts of others. So we at Cisco disagreed with that entire notion. And this led to Cisco security teams and researchers devising a novel way of detecting malware in encrypted streams without decryption, something that I'm not aware of anyone else being able to do. And this is because there are extremely subtle traffic signatures which humans aren't able to detect and correlate, but which a computer can. Now, using AI, we can spot these subtle signatures to detect malware and employ ML to improve the detection rate, which, by the way, sits at above 99.9%. And to illustrate why or what the attack landscape looks like, well, these are just some of the figures for cybersecurity events inside of Cisco in just a single day. Now, imagine if you were the person tasked to look at these 28 billion net flows. I don't think I can even imagine the size of the spreadsheet I'd need for this. I mean, I don't even know if Excel has enough, cells, but it's a huge number. And by the way, NetFlow comes from our StealthWatch product, which, whilst outside the scope of this talk, basically turns the network into a sensor which captures data flows and associated attributes. And this way we can capture everything that comes into the network. And from there, we can employ AI and ML to analyze those 28 billion net flows, utilizing ML techniques to extract the data points we need to tell ETA what is benign traffic and what is potentially malicious. So in other words, we first benchmark and baseline on normal. It then learns what the malware does, not based on a signature, but behaviors. And this is especially prevalent when we're talking about day zero attacks, which may look different to other malware, but which we still use the same mechanisms and behavior as normal malware to infect and disrupt. We all use all the concepts of ML to continuously learn, benchmark, and update, with any threats seen in the wild being fed into that intelligence by Talos, which is Cisco's own security research organization. And anything that looks potentially malicious goes into our information security playbook, which tells us what response to apply to a particular type of malware. And by the way, we have over 100 possible types of malware in our playbook, which we use to mitigate and remediate based on identification. So again, just to summarize that, we baseline on normal, giving information on what malware looks like, employing ML techniques to extract those key observable features in the data, and build these into detectors in the network. So when encrypted malware comes in, we're able to detect it without decryption. And I know there are some of you out there who may be interested in seeing what those observable features are. Well, let me show you. So first of all, what we're looking at is anything that we can get for free. And by free, I mean unencrypted headers and fields, such as the initial data packet. So this can take details such as features and SSL headers for HTTPS connections, as an example. We also look at the sequencing of packet lengths and times, which gives us visibility beyond the initial data packet. This lets us ascertain what kind of content is being delivered through the connection. And my favorite example of this is small packets pinging out in a very uniform fashion, which is indicative of malware dialing home to a command and control endpoint in the attacker's infrastructure. And finally, we employ our global threat intelligence map to feed into these decisions, as we have a lot of visibility into the global threat landscape. We have visibility of where the bad actors live on the internet, the attacker infrastructure, or servers, which could be exploited or used as part of a future attack. Now, all this provides us a holistic context for what ETA and other Cisco security solutions will do. So this takes me to the end of my presentation. I hope you have enjoyed it and found it informative. Since we're slightly capped on time, it's going to be a little bit difficult to go too much into depth. But if you do want to find out more, I really do encourage you to visit the Cisco AI website. Now, there was a very long link that I could have pasted on here, but I don't think that's too useful to you. So simply go on Google and Google for Cisco AI. It should be the very first entry. So once again, I have been Richard Liu, and thank you all so much for taking the time to listen to me. Look forward to hearing from you all in our Q&A session.
Thank you, Richard. That's a fascinating presentation. One of the figures that really jumped out at me there was 1.2 trillion security events every day. I mean, I can't even comprehend what that size is, but I'm assuming that number is only increasing, certainly not decreasing.
Oh yes, absolutely. As the attack vector is increasing, we do find that there's much more attack surface now than before, because there are so many more things and devices and entities just in the network. And because of that expanded attack surface, there's ever more ways or attempts at trying to breach an organization's network.
Now, we know security and message security is a very sensitive subject around the world at the moment. So if I've got this right, you don't necessarily have to break the encryption and get into messages or content itself to spot this malicious activity. You're really looking at patterns and putting on layers of different intelligence and learning to spot without actually going into the encryption.
That's absolutely correct, yes. It's a combination of our SDA, Software Defined Access solution, which is our premier campus LAN product, including other elements of our security portfolio. And because of the way that all our solutions come together, we are then able to get that data, employ ML and AI, as you say, to find all of those malware signatures inside of the encrypted data. And because we don't have to decrypt, it ensures business continuity.
And also, when you talk about day zero malware behavior, what do you mean by day zero?
So day zero attack is referring normally to an attack which hasn't been seen in a while before. It could be a mutation or refactoring of a previously known malware, but which won't have the same signature because the code will have been modified. Or alternatively, it could be an exploit which nobody knows about yet. And these are especially dangerous because if we're not aware of it, it's very difficult to guard against it. So where the Cisco solution differs is that it looks for behavior rather than signatures, meaning that if it's doing something, then we will know about it, because all malware pretty much acts in the same way. It will try to download a piece of code, it will try to call out to command and control infrastructure in attacker's infrastructure, and it will try to do all of this inside of traffic. Now, when we're able to pick up those little pings in the example that I shared, we're able to ascertain, with a very high degree of accuracy, that actually this looks very suspicious. And what we're able to then do is alert someone so that they can look at it and remediate. Or it could lend itself into an automated workflow where if that's picked up, it will automatically be shut down and we'll start remediation from there.
Richard, thanks once again, and we'll be seeing you shortly for our Q&A session. If you haven't already done so, then please send in your questions to Richard and all our speakers today. We'll be hosting the Q&A session at the conclusion of the presentations. Still to come, we have Paul Adams of Nokia on the intriguingly titled Doomsday Pizza and the AI Assembly Line, and Detlef Nauk of BT, who will be telling us more about how to interpret AI systems. Don't go away.